Hello, my name is Mark. I'm one of the teachers of electronics at Suffolk One. Due to the COVID restrictions that are present in place, myself and Tony have put together a video to explain how we teach and what is involved with electronics at Suffolk One. You'll be taught by myself and you'll be taught by Tony as well. We put some details there about ourselves. I'm going to give you about 30 seconds or so just to have a quick read. This slide shows that we're presently teaching the WJEC Electronics A-level course. We've been teaching it now for 3 years. At the bottom there I've put a link to where you can access the whole specification from the WJEC site itself. On this slide here you can see that a textbook is provided for all the students. We have a book for year 1 and we have a book for year 2. These are based upon the digital version of the book that the exam board has provided, so the students at any time can access the internet, or in fact our Moodle format has these books for them if they don't happen to have the textbook with them. This slide shows you basically how we sort of examine the A-level course. Over the 2 years you'll learn lots and lots of different aspects of electronics. Throughout the whole course you'll be learning how to build. In that process of learning how to build, it will put you in a position at the end of the course. We'll probably start around sort of September, October actually in the second year. We sort of start the extended projects. These only account for 20% of the final mark, but it puts together everything that you've learned in terms of building, testing, and also writing up a report. The 80% of your course is by an examination, and you can see there's 2 papers there, 1 and 2. On this slide here, we've put the results for the last 3 years for our electronics. As you can see, they've done very well. Indeed, we're very, very proud of what our students have achieved. And many of them have gone on to do engineering or electronics type degrees based upon the grades that they've achieved. This slide here is just showing you where electronics might lead to. Besides being incredibly interesting, what it will do is it'll lead you into lots of careers within engineering. Clearly, you're going to learn some skills which you can apply to other jobs and careers as well. There's not many people taking electronics, so it really is going to put you in a sort of a good position. This is an example of about half of somebody's project work. You can see, but what it's showing you is the proto boards that you'll be actually building and testing all your circuits on. This slide is just emphasizing the fact that electronics is a very practical, hands-on subject. We would expect you to build pretty much every lesson in the first year. There is theory in the lessons as well, which uses maths, and over the duration of the course you'll get faster and more efficient at building. All the resources that myself and Tony use with you are there available for you to use at home, and we put these on what's called a virtual learning platform, and it's called Moodle. The next slide will show you a bit more detail. This slide shows you that you would be going to the IES Electronics area, and that's where you'll actually find our work. On this slide it shows that all the lessons are separated into lesson 1 to 50. You will find that there's a PowerPoint, there's homework questions, homework answers, any other resources that we think you might use. Within this whole Moodle area, we have a massive revision chapter as well, with loads of resources for you to use when you get closer to do the exams. In the event that COVID-19 is still with us in September, we will be able to teach, and we have been teaching the lessons on Microsoft Teams. This is just an example of a typical lesson. All the lessons are actually recorded. If the students want to revisit and go over something that we've done online, the facility is there for them to use on MS Teams as well. When using MS Teams, students will talk to us, also put comments in chat. These are instantaneous, and we give answers instantaneously back as well. What this slide will show us here is at home and in college as well, and it's home all the time, you'll have remote access to our circuit designing software, which is called Circuit Wizard. You may have heard of it. So it's a very useful tool, so you can design and analyze circuits. You'll notice that the circuit at the bottom there has got a black screen. That's because we're running on logic format, so we can actually see the highs and lows in the circuit, whereas the one in the white screen above is more for printing things off or just looking at the components themselves. So it's a very powerful tool, but you will have access in college and of course at home all the time. Um, yeah. Okay. What I've got here is a slide showing breadboards, our proto boards. These boards, you'll have your own board, if not two, depending on what you're building. We always try and follow the convention that red is positive and black is negative. It makes life a lot easier for Tony and I actually checking your circuits built correctly, and yourselves as well. You'll notice that there's these sections which are isolated, or lines. We can see vertically looking at the board there. That's so you can put an integrated circuit across there, so you don't short circuit either side of its legs. Okay. This slide shows that we assume that you have no building knowledge before. Some of you may have. Hopefully you can assist others, because you will work in twos for some of the time. This circuit here is just a simple transistor driver, and we spent a bit of time just learning which are the right connections for the actual transistors themselves. This is one of the early circuits that you'll actually be building, and this is a simple transistor driver with a light dependent resistor, diode and the transistor and its protective resistance and its correct biasing. As you can see from this diagram, circuits will become a little bit more complicated, and we're using an integrated circuit. So again, this one is just a 5.5 astable flashing circuit that we'll build within the first couple of months. As it's quite an early build, what we often do is we provide you with the circuit diagram, but if anyone needs any help, we do actually provide photographs of what the circuit should look like, and hopefully you can see there from what I said earlier, we will have the 5 volts going to red and the black going to 0, so the convention is actually held all the time. As I said earlier, electronics is a very practical subject, and if in the unfortunate event that we still have COVID with us in September, just to confirm that lessons at the moment are taking place in college in a COVID compliant way, keeping us and the students safe. In the latter part of the first year, we actually look at using flowcharts, because we will start to look at using programmable chips, a bit like Arduino, but we actually use the pickaxe system. If you'd been with us today, you would have actually been in the electronics lab. There's one photograph of it. Here is another photograph of it, slightly better lighting. What you can see in this photograph is some of the components that we have in little trays, and in large cupboards we keep some of the large apparatus that you need for powering the circuits and also testing the circuits. At the moment we tend to use mainly digital picoscopes, oscilloscopes, which everybody finds a bit easier to do screenshots for. And finally, some contact details for myself and Tony. Please contact us if you have any questions, and thank you very much for listening to the video.